Hey guys, welcome back to my channel, and today we're going to be talking about limits. So you can think of limits as something that's going to approach a certain value. So for example, you would use limits when you have to do with tangents or velocities, and basically how it works, the definition of a limit is limit, so you just write lim as x is approaching a. So a is just an arbitrary value, so like 1, 2, 3, any value. And then f of x, which is basically the function, and it's approaching a value equal to L. So the way you say it is that this is known as the limit of f of x, as x is approaching a value of a and causing it to get a value, as x is approaching a value of a and causing it to get a value of L. So as x goes to a, it goes to a certain value of L. So for example, if let's say the limit as x goes to 3, which is the value of f of x, would equal 6. So as x goes to 3, f of x is going to 6, that arbitrary value, L. So that means as x is going to a, f of x is going to L, is the way you would consider how you would write this. So there are two different types of limits that you can observe on a graph. So let's say I draw a graph and you have a graph like this and it asks you to find the limit. So the limit can be a closed point or it can be an open point like this. So that means here, this is considered a hole, so you can have a limit at a hole. So a lot of people think, oh, like it's approaching a value, so why would it be a hole? But technically, in limits, it can be a closed value or an open value, and it's just the point that it's approaching that value. It is not. It's basically approaching this part here and going to this value is what the overall message is of a limit. So let's go with an example. So the limit as x is going to an arbitrary value of 1. And let's say our function is xo minus 1 over x squared minus 1, and it asks you to find what it's equal to. So in this situation, the best way you solve any type of limit is that you plug in values that are close to it so you can understand what it's going to approach or what value of L it's going to approach. This is basically L. So for example, we always need to start with the values closer. So you can start from the left side or the right side. Left side meaning I can do 0.99, plug in 0.99 for x, and then plug in 0.999 for x, and then plug in 0.99949s, because this basically means it's more approximation to 1. So the more closer the approximation is to 1, the more accurate your limit value or your L is going to be. So when I plug in 0.99, I get, for x, I get 0.5025 approximately. Now if I plug in this value for x, I get 0.5003. And lastly, if I plug in 0.9999, which is a lot more closer than 0.99 to 1, you get 0.50002 approximately. So as you notice, the more closer you are to 1, you're eventually approaching some type of value, and that value is 0.5. So that means as x goes to 1, this function f of x or g of x or whatever the function is, approaching an L value of 0.5. Now all these are from the left side, which means you're going from the left. So you're doing 0.99, 0.999, 0.9999999. Now let's say we want to go from the right, which means you want to find values that are greater than 1 and use those, but it's greater than 1 but closer to 1. So let's say I do the same thing, except I'm going to use 1.01, 1.001, and 1.0001, so 0, 0, 0, 3 zeros and 1. Now, let's say I plug in this value for x, right? I get 0.4975. In the next one, I get 0.4998. And then this one, I get 0.4999. And just like we did with 0.99, 0.999, and triple and quadruple 4 nines, the same way we're going to do this. If you notice, it's eventually approaching the same value, which is 0.5. So it's safe to assume that the limit as x goes to 1, the function f of x is going to 0.5. So just remember, in terms of limits, whenever you're trying to find the limit, most of the time when you plug in this value, you're going to get something as 0 over 0, which isn't, you shouldn't get that value, that's bad. So when you get this type of situation, the best way to solve the problem is to just plug in values that are close to 1 from the left side or the right side and see what value is approaching. And that would give you your limit. All right. So thanks for watching. If you have any questions, please put them down below. If you have any comments and any topics that you want me to cover that you feel that I should cover, anything you would like. And once again, thank you.